Okay, let's talk a little bit about analog versus digital signals. So an analog signal can vary, so it can either be on or it can be off or it can be somewhere in between. A digital signal is either on or it's off. It's binary, ones and zeros. Either it's happening or it's not. So in this example, we have an input, which is a thermocouple, we have a temperature controller, and then we have an output, which is an alarm output like a lamp. So either the lamp is on or it's off, depending on its relation to the set point. So the input, which is that thermocouple, is going to vary with response to temperature. So it's either going to provide a smaller millivolt signal or a larger one, depending on the process. And then the temp controller is either going to give an on or an off to the output. So the light is either on or it's off, depending again as to whether or not your temp controller is saying you're above the set point or not. So that's the basic analog versus digital. Now let's go into a little more complicated example. We'll take a temp controller, a power controller, which is that SCR. We've got a 3-pole contactor for our limit. We've got the limit controller. We've got our heater with our whispering friends, the informats, the limit thermocouple and the process thermocouple. We have an alarm and a PLC. So the power goes into the SCR, it comes out through the SCR, through that contactor for the limit, and then goes on to the heater. Let's talk about the I/O. So we're going to start with the temp controller. As you can see, there's an analog output going to that SCR, 4 to 20 milliamp. So 4 milliamp would be off completely, 20 milliamp would be on 100%, and you can be somewhere in the middle. You could be 10 milliamps or 15 milliamps. And what you're saying is, as a function of time, we want the power to be on a percentage, a portion. So 50% would be 11 milliamps or 12 milliamps, right? 75% would be more like 15 or 16 milliamps, and it'll be on 75% of power. So that's your analog signal. Your power goes through the SCR, so again, power is gonna flow into our contactor, which then is going to make a connection, and then power continues to flow into the heater. And you can see that's a discrete connection going to the limit controller, so that's digital. It's either on or it's off going to that limit controller, because that's not going to be a proportional signal. Then you got our limit thermocouple informing to the limit controller, and that's an analog. It's just telling you what the current process temperature is. Process thermocouple is going to be doing the same thing to the temp controller. So again, that's analog, millivolt signal varying with response to temperature. Now the temperature controller is going to do a digital to the alarm. So that alarm is on or it's off. And that's saying, hey, I'm above the set point, I need to be on. That's never going to be a proportional signal. But then we want to communicate back into the PLC, so we're going to retransmit that process thermocouple value, and that retransmission is a 4 to 20, so it's an analog going back to the SCADA for the rest of the company. So that's a fairly comprehensive example of digital versus analog I/O. In our next example, we're going to take an application and we're going to list out what are the inputs and what are the outputs. Are they digital or are they analog? And we'll go from there. Thank you.